Welcome back everyone. Here for this video we are going to solve for the 6 trigonometric ratios of angle theta and angle alpha. But in order for us to do that, we need to complete all the side measurements of this given right triangle. Since this is a right triangle and we're talking about measurements of sides, we can identify the 6 trigonometric ratios or the exact value of the 6 trigonometric ratios of both angle theta and angle alpha if we can solve or we are done solving the measurement of the unknown side. And since this is a right triangle, we can use here the Pythagorean theorem, which states that the square of the hypotenuse is equal to the sum of the squares of the two legs of the right triangle. In this case, we need to identify which is the hypotenuse. The hypotenuse is the longest side of a right triangle, and it's also the side directly opposite your 90-degree angle. That would mean we can say C being 15 squared is equal to A. Now you could decide whether it should be X or whether it's 10. Just for the play of numbers or expressions, let me just use X, and so that I will have 10 squared for our B squared. So you can solve X squared. I'm using symmetric property, and properties of equality here is actually equal to 15 squared minus 10 squared. X squared now is the result when we subtract 2 to 5, that's 15 squared, and 100, that's your 10 squared. X squared is now equal to 125. Since we're solving for x and not x squared, we're going to take the root of both sides. So x is equal to, don't forget that it should be plus minus, square root of 125, which could give you a result of x, which is equal to plus minus, simplifying this further, you have 5 square root of 5, because 125 is 25 times 5, sorry, that's 5 square root of 5. And since we are dealing with measurements, we will only accept the value of x being the positive 5 square root of 5. This is now the value of x, which will be used to solve for the 6 trigonometric ratios of both angles theta and alpha. Let me extend this here so that we could have a lot of space for additional computations and discussions. So let's start first with angle theta. This is your angle theta. That would mean this is your opposite side of angle theta. X, which measures 5 square root of 5 units. Yeah, I forgot to place units, so I'm going to place here units. Even if it doesn't have any unit, let's just place units to denote that it's the measurement of a side. So that's 5 square root of 5 for angle theta. This is your adjacent side. And 15 will always be your hypotenuse. So with this, we can now start solving the values of the 6 trigonometric ratios of theta. Let's start with cosine. Cosine is cosine theta, or again generally cosine is the ratio of the adjacent and the hypotenuse side. By the way, if you have forgotten, we are going to use here this mnemonic technique. So SOH-CAH, and TOA. I just started with cosine, so it corresponds here. Cosine is the ratio of your adjacent side over your hypotenuse. The adjacent side is 5 square root of 5 units, as computed a while ago, over 15. Simplifying it further, because 5 can be divided, or there's a certain factor for 15 that is 5, you are left here with 3. So the cosine theta is equal to square root of 5 over 3. This is your first trigonometric ratio for angle theta. Let's proceed to the next. Let's have sine theta. Sine theta, according to the SOH-CAH-TOA, is the ratio of the opposite side over your hypotenuse. Your opposite side is exactly given as 10, and your hypotenuse is exactly given as 15. So this is not 1/3. That's given as 2, and then 3. 2/3. This is the simplified value, and you are asked to always simplify for sine theta. Let's proceed to the third one, tangent theta. Tangent theta is the ratio of opposite side over adjacent side. Opposite is 10. Your adjacent is 5 square root of 5. Of course, 10 has also a factor of 5, so you could write this as 2 over square root of 5. However, since a radical expression is found in your denominator, we are going to rationalize this or multiply a certain value equal to 1 that could remove or rationalize the denominator, and that's actually square root of 5, square root of 5 here, so that your denominator will become square root of 25, which is just 5, and no need to worry if your numerator will contain a radical expression, because it's the denominator that we are concerned with. So these are your first 3 trigonometric ratios for theta. The next trigonometric ratios are the sine, secant, cosecant, and cotangent. Let's start with cotangent. Now, cotangent can still be computed as the ratio between a adjacent side and opposite side. Now you can input the values here, but you could actually do a little shortcut here. The shortcut I'm telling you is that we just need to reciprocate the value of tangent theta, because tangent theta is the reciprocal of cotangent theta. And instead of using this final answer here, because if you're going to do or reciprocate this, the radical expression will appear now in your denominator. So instead of that, we will be using this value earlier, so that we will no longer rationalize. You'll have square root of 5 over 2. The next trigonometric ratio is known as secant theta. Secant theta is the reciprocal of cosine theta. So cosine theta is the ratio adjacent over hypotenuse. In short, secant theta is the ratio of hypotenuse over adjacent. And we are just going to reciprocate the answer here. You will get a result of 3 over square root of 5. That's the reciprocal of cosine. But notice again, we are going to rationalize here. So we multiply the numerator and denominator by the same expression, square root of 5, so that this is just 1. So you will have 3 square root of 5 over square root of 25, which is just 5. Finally, for our cosecant theta, this is the reciprocal of your sine. So sine is opposite over hypotenuse. We just simply use here hypotenuse over the opposite side, or the reciprocal of 2/3, which is 3/2. So these are the 6 trigonometric ratios of angle theta. Let's proceed to angle alpha, and let's use a different color here, since the value of your opposite side and your adjacent side will now become different. So for angle alpha, if this is now your reference angle, that the value of this side, which measures 10, earlier it was the opposite side for angle theta, now this becomes your adjacent side. The adjacent side of x, which measures 5 square root of 5 as computed earlier using the Pythagorean theorem, will now become your opposite side. And the hypotenuse is still your hypotenuse. So in this case, and then after identifying that, we can now proceed to the 6 trigonometric functions, or ratios rather, of alpha. So cosine alpha is equal to adjacent over hypotenuse. The adjacent is no longer 5 square root of 5, but it's 10. It's 10 over hypotenuse 15. This is again, in simplified form, 2/3. Sine alpha is SOH. So it's SOH, opposite over adjacent. Your opposite now is 5 square root of 5. That's the opposite side of angle alpha, over hypotenuse, which is 15. So simplifying that further, divisible by 5, so you will have a result of square root of 5 over 3. So let's proceed now to your tangent alpha. Tangent alpha is TOA. Opposite now is 5 square root of 5 over adjacent, which is 10. So that's divisible by 5. So you have square root of 5 over 2. Cotangent alpha is the reciprocal of your tangent alpha. So this one here, the reciprocal of that is 2 over square root of 5. And to rationalize it, we always rationalize denominators when it has a radical expression rather. So you have 2 square root of 5 over square root of 25, which is 5. Before we proceed to secant and cosecant, I would like you to bring your attention to this scenario. Look at what happened to cosine theta and sine alpha. They have the same value of 5 square root of 3, 5 square root of 3. Your sine theta of 2/3 is your cosine alpha 2/3. This is because when you change your reference angle, the measurement of your adjacent and opposite sides were interchanged, and that would mean your assignment of A and O labels are now changed. This is also true with your tangent earlier, which is 2 square root of 5 over 5, is now cotangent alpha 2 square root of 5 over 5. It's also true with your cotangent theta earlier, which becomes your tangent alpha of square root of 5 over 2. With this concept, we are also expecting that secant theta will become our cosecant alpha, that's alpha, sorry, and that your cosecant theta will become your secant alpha. Let's do that, but first, let's connect again secant to cosine, because secant is the reciprocal of cosine. 2/3 So your second alpha is 3/2. Look at what happened. Again, second alpha is your cosecant theta. So cosecant alpha should be 3 squared root of 5 over 5. Let's find out by using the relationship of sine and cosecant, which is the reciprocal of this. So you will get 3 over square root of 5, which needs rationalization. So you have square root of 5, square root of 5. So you have 3 square root of 5 over square root of 25, which is just equal to 5. See? They were just interchanged. So this 6 here, the blue colored values, are your 6 trigonometric ratios for your alpha. And the answers earlier were for your theta. So this is how we solve trigonometric ratios, especially for two different angles, thereby changing the point or angle of reference for your 6 trigonometric ratios.